In this video, we'll show that how to find the Thevenin equivalent circuit. So first of all, the Thevenin theorem. This theorem states that any complicated circuit can be expressed as a voltage source with a resistance in series. So that is the voltage source with a resistance in series, and this voltage is called Thevenin voltage and this resistance is called Thevenin resistance, and they are connected with the load resistance, that is RL. Okay, now take an example like so the question is, that is the circuit. And the EMF of the source is E, and internal resistance of the source smaller, that is R1 resistance, that is R2 resistance, and that is the load resistance, and we have to find the current through this load. So the question is to find the current through the load resistance. So that is how much is the I. To find the solution of this question, we have to convert it to the Thevenin equivalent circuit. So let's start. First, the step 1 to convert it to Thevenin equivalent circuit. First of all, remove the load resistance RL. So first of all, remove this load and draw the circuit again. Okay, and that is removed, and if this is A and this is B terminal, then that is A and that is B, and that is EMF comma internal resistance R1, that is R2. Okay, now we have to go to the step 2, and in this step we have to find the voltage or the open circuit voltage across the terminal A and B. Okay, so find the voltage. The voltage across A and B is equal to the voltage across this R2 resistance. So you can see that the current in this circuit is like this, in this direction, because there is no current through the A, because that is open circuit, so there is no current, so the current is in this direction only. So by the voltage divider rule, the voltage at the resistance R2 is equal to the EMF into R2 by R1 plus R2, and you can see that is the internal resistance of the battery source, so we have to add this, that is smaller, so add this internal resistance with that. Thus we get the voltage across R2 and across AV, and that is called the Thevenin voltage. Thus we get the Thevenin voltage of the circuit. Now we go to the step 3. And the step 3 says us that remove all the voltage or current source of the circuit, so and leave their internal resistance. So in this circuit there is only one voltage source, so we have to remove this and replace with the internal resistance. So write this, the internal resistance smaller, that is R1, that is R2, and that is terminal A and that is terminal B. Now we go to the step 4. And at this step we find the equivalent resistance from terminal A and B. So across terminal A and B, we have to find the equivalent resistance of this circuit. So across A and B, to find this, we have to redraw the equivalent circuit. So you can see that in this circuit the resistance R1 and small r are in series. So we can join this to circuit resistance. So that is R1 plus small r, and R2 is in parallel with them, and that is the terminal A and that is the terminal B. And now in this circuit, this one and this one are in parallel, so the equivalent resistance of this will be replaced by only one resistance, and that is the terminal A, that is the terminal V, and the equivalent resistance is given by the parallel combination of these two, that is by this multiplication by addition of the resistance. And this resistance across the terminal A and B is called the Thevenin resistance. So that is the RTH. Okay. Thus, in this way we get the Thevenin resistance, that is RTH, that is this R1 plus R into R2 by R1 plus R2 plus small r, and we get the Thevenin voltage there. So that is the Thevenin voltage. Now we can convert it to the Thevenin equivalent circuit, because we get the value of Vthevenin and Rthevenin, and R load is given, load resistance is given, so we can easily convert it to the Thevenin equivalent circuit. So draw the Thevenin equivalent circuit is like that. That is terminal A, that is terminal B, and that is the load given, and we calculated Vthevenin, Rthevenin, and now we can easily find the current through the load resistance, that is RL. So you can see the current through this resistance I equal to Vthevenin, that is voltage, by total resistance, that is Rthevenin plus RL. Okay. Thus in this way we get the current through the load resistance by converting the circuit to Thevenin equivalent circuit.